Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is 3 recommendations to make your architecture process better. 3 practices that I believe you should adopt in 2025 or as soon as you can in your process to obtain software architecture. The first one is diagrams as code. Diagrams as code are a very powerful tool right now. So basically what you can do is to create diagrams through the use of markup languages. The one I've been using mostly is PlantUML, but there are 2 others. There's Mermaid and there's also Structurizer that is optimized for C4 modeling. Now these tools can kind of mix and match together, but if you want an easy start, it would be, from my point of view, PlantUML is pretty easy to start. Now let me show you what you have here on the screen in case you are watching this. Is a diagram that I used to present part of our microservices, architecting microservices course. And basically you have a kind of markup that says, there's a title, a description, and then you can define things like packages, nodes, components inside the packages, databases, and then interaction between these things. So now this is one kind of diagram, but you can also have diagrams like sequence diagrams, you can have class diagrams, you can have all kinds of different UML diagrams. PlantUML doesn't support all UML diagrams. It would be also very difficult because right now there are tens of diagrams, but it supports the ones that are most important and mostly used. And it's really nice to have this because on one hand you can store your diagrams with the code in text format. You can store them on Git. You can look at changes. You can update them. And they are version controlled. They can be then transformed into PNG files or SVG files. And SVG is a general format that it can scale as much as you want. So you can basically print a poster from your diagram and place it on your walls if you need to. You can include them into your documents. And since I'm here, I could also talk about having the documents in Markdown and then using tools like Pandoc to generate the final version, like PDFs, the releases for these documents. And you can include the diagrams in Markdown files. So this makes everything easier in terms of managing diagrams. You don't need a ton of tools. You just need a text editor, or in this case, even better, Visual Studio Code. I'm sure other tools have this, but Visual Studio Code has this really nice preview if you add the extension for PlantUML. And basically you can change some things. Let's say if we want to change some stuff, and it will show me a preview here. Now, of course, with these tools, there's one small problem which you should be aware of. They do require a little bit of getting used to because you can no longer drag and drop things. So it's no longer what you see is what you get. But instead, you write the markup and the tool will align and organize your diagram based on its own rules. So you cannot control positioning of the various parts of the diagram. Typically, the way to deal with this is to first write the diagram, and this is from my experience. First, write the diagram without paying attention too much to how it's displayed, because what I've noticed is once you go into the full diagram, it tends to get better. If you try to play around with it and do all kinds of tweaks to make it align in different ways, you are just making it hard for yourself. You are working extra hard for nothing. So instead, focus on creating the diagram that you need with all the elements, and only afterwards go and see if you need to do anything to kind of arrange or align things. Because there are some tricks. You can add some hidden lines, you can do various stuff for this, but don't worry in the beginning. So diagrams as code, definitely a go from my point of view. You should do it. It's very useful. It will enable developers to modify diagrams, to update diagrams, to discuss on diagrams. You will not need extremely complex tools to deal with those, and it's, yeah, generally it's much better, I believe. And imagine the integrations you could have with this, because being a textual format, and since you have the tools that interpret those, you can also write your own add-ons or do all kind of things to bring the diagrams to more integrated to your architecture or to your real code in the way you need to. So it's pretty cool. I don't mean generate the code from your diagrams. That's not what I need. Not what I mean. It's not a good idea. But what I mean is you could add, for example, architectural tests or other constraints on your diagrams. And that can be very helpful. Or link to diagrams, one of the next topics here, the next artifact which I am proposing to you, and that is architecture decision records. Architecture decision records have been around for a while, but and some people have adopted them, but I feel that not enough based on my information from people I work with. And these are really useful. So an architecture decision record is meant to solve a specific problem with architecture, and that is, we always ask the question when we go into a new project. I'm getting hired in a new team, I'm going there, I'm looking at the code. Why do we have this structure, right? That's the question. And often people don't know anymore because teams change, the people who made the decisions in the beginning might have left, and so on. So because of that, it's useful to have these records that document the important decisions in our architecture. And this doesn't have to be very complex. It's a very simple document, usually written in Markdown, and they have an index, they have a date, they have a title, they have a status. It has a context, a decision, consequences, alternatives, and that's it. That's a bit of a description that you need. So here I have an example. Use LaTeX for document generation is the name. Date 25 May 2021. Status accepted. The status can be draft, in progress, or rejected. You could always store the rejected proposals as well. Context to avoid to reduce copy-paste errors, we need to automatically generate common documents. A third-party tool is required in order to create PDF and/or Word documents. Decision, we have decided to use LaTeX. This is an example, right? It has a context, but don't worry about that. So there are some consequences here because the LaTeX syntax is unusual. It's a very powerful engine, but it's not easy to understand. Alternatives, we have looked at a number of alternatives, Pandoc plus Markdown, XK, HTML to PDF, and other HTML to PDF tools, and libraries that produce PDF files. So this is an example of a decision record. Now, this is very short, very brief. And the way you would use this is, let's say, as a developer, you see something, you have an idea for an improvement in your architecture. You can write such a architecture decision record with a status, draft or pending approval, or depending on what process you decide to use, and then review it with software architects, with your colleagues, and then after a while you either fill it in and you decide whether to move with it, so accept it or reject it, and then write down the reasons for rejection, because that's also very useful information to have. This is about the knowledge of architecture that you are building in time. Of course, architects can do the same, and imagine how cool it is to have this in combination with diagrams as code, because this is Markdown. You can embed diagrams as code here. You can embed plant UML code or the images, and you can see those as they evolve, right? So it's really good. Now, what would these decisions be? They need to be decisions related to the architecture, so not necessarily about a specific part of the code, but more about the general things, like we decide to use a design pattern for asynchronous calls. We start using this all over the place. For a specific component, we decide to move responsibilities from one component to another component. We decide to split from a monolith to extract a component as a service. All kinds of stuff like that, right? We decide to replace a microservice with a serverless implementation. So there are all kinds of things like that you should be documenting as a record. Now, this was created with a tool that's called ADR-tools, written by NetPrice, but there are other alternatives to this. So it's not the only tool. There are a lot of open source tools. There are a lot of different templates you can pick from. I like this template because it's very simple, very to the point. So it's basically what everybody needs. And this takes us to the third one, which is prototypes. I've long been a fan of using prototypes to validate architectural decisions. So let's say you come with an idea for an architectural decision, and you say, okay, maybe we could use another message passing tool, like RabbitMQ instead of ZeroMQ, because it would help us with specific capabilities. Cool. So now you start by writing an ADR for this, an ADR proposal, and then you go into, okay, how do we validate this? Because We can look at documentation, we can read through the materials, but we have to be aware that a lot of the materials out there on these tools are marketing. So you need to take into account more aspects than just what you see in the official documentation. And the best way to deal with that is by writing a prototype. Now, usually this was a very difficult thing, or maybe not as difficult, but time consuming, right? Because you'd have to go read through documentation, understand everything, write down an example, make it work, and so on. And now, with the advent of AI tools, I think there's a much better chance to create prototypes and throw away prototypes in particular that prove a certain scenario. So let's say you want to implement some kind of messaging capability inside your application. You need to choose between RabbitMQ, ZeroMQ, Kafka. You can make first a comparison between those three, and then the next step would be to implement the common pattern that you have in your application and to see how this works in these three tools. And now what you can do is to use an AI assistant like GitHub Copilot or Claude or whatever, Aider, and generate the code and work with it, of course, to generate the code that you need and adjust the code as you need. With the intention of just showing how it would work, okay? And this is very helpful because you get something that works quite easily based on my experience. Now, the next step is harder, which is to adapt it to your specific scenario. But you still need it to do that, and you still need it to start from something that works, and it's really great to start in this way. Now, this poses another challenge, particularly in large companies that we are working with, in that it's very difficult to convince IT people to install these things for you and make them work. And, you know, they need to pass through security recommendations. And that's perfectly fine if you need to do production capable system. Then absolutely, they should go through security. They should go through legal. They should go through licensing, and everybody should make sure that this is something that you can use. But it's too early to do that before you can actually validate that it's helpful for you, that it's useful. So because of this, I believe there should be a fourth one. So this is an extra practice that you should adopt for your architecture, which is slightly more difficult, but it will definitely speed up development, architecture, and infrastructure work. And that is create a separate tech lab inside your, or separate from your production systems, where developers, architects can try out, experiment with various capabilities, with various tools, with various applications that you can use. And this is becoming easier and easier to do because you have cloud. So you could, for example, have a separate AWS account that is just for TechLab. And you have the AI assistants that can help you with setting up and automating your experiment. And you have these AI assistants that can help you with generating the code that you need in order to have a functional version. And then you can at least look at that and say, oh, okay, so this looks kind of like what we need. Let's make some more adjustments. Let's invest a little bit more time in this experiment. You could say maybe this doesn't work for us. We need something different. That's perfectly fine. But once you validate and you go into your architecture decision record and say, okay, so this is something that we actually validate and we believe it's very useful, then you can go through the whole process of making sure that the tools that you need are have the appropriate licenses, support, and everything else that you might need. And yeah, that in that process, it might be refused, and then you might need to go with an alternative. But that's the game. Ideally, you'd have everybody involved from the beginning, but those processes tend to take very long, like security assessments and legal and all that. So because of that, one option is to actually run the experiment, and then once you're sure, go through this whole certification process, let's say. So yeah, these are 3+1 practices that I believe will help your architecture process in 2025 and beyond. Let me know what you think in the comments. We love comments, and honestly, we had less comments in the past few videos, and I missed that. Let us know in the comments. Do you use any of these practices? What do you think about those? Does this make sense? Is there anything else that you would like to address regarding your software architecture? Let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.